Assalamualaikum and good day everyone. So today we are going into the second part of the 5.2 on liquid. So previously we have learned about the physical properties of liquid based on their intermolecular forces, the molecular arrangement and also the molecular motion. Okay, and then now kita nak tengok pula the vaporization process, condensation process based on the kinetic molecular theory, and later on kita akan start masuk pasal vapor pressure, boiling point, the boiling process itself, and to see the relationship between the intermolecular forces to the vapor pressure and also between the vapor pressure and temperature. Okay, so kita akan cover the whole thing dekat sini sekarang ni. Okay, so what is a vaporization process? Okay, so vaporization process is a process in which liquid particles with sufficient energy that escapes from the liquid surface and enter the gas phase. Bermaksud, it is a transition process between liquid phase to the gas phase. Okay, so ataupun yang ni ada cara lain lah untuk describe the vaporization process. It is a process in which liquid transform into gas. So what happened is the molecule in a liquid, they move quite freely, not as freely as a gas, but they still have tiny bits of spaces, right? So they can still move around. Okay, so each molecule they have a different magnitude of kinetic energy. So what happened is, if the molecules they have a relatively high kinetic energy, okay, so bila ada high kinetic energy tu nanti dia akan transform pergi gas lah. Okay, because anything with a very high kinetic energy itu adalah gas particle kan. Okay, so when kinetic energy is sufficient enough to overcome the attractive forces that holds the liquid particles together, so the molecules loosen themselves up and they evaporated off. So diorang akan leave the surface of the liquid particles. Okay, so dia akan jadi gas lepas tu. So evaporation. Okay, so evaporation is a process where the molecule they escape from liquid to gas state through the surface of a liquid at any temperature below the boiling point. Okay, so bawah vaporization process ni ada dua sebenarnya. Satu adalah evaporation, another one adalah boiling. Okay, so dua-dua ni adalah proses kita tengok daripada liquid pergi kepada gas. Okay, it's just that dia ada a different condition lah, nanti kita akan tengok on that later on. Okay, so kalau evaporation itself, it happens at any temperature. Okay, at any temperature, and that temperature is usually the one that below the boiling point punya temperature lah. Okay, and then it only happens yang dekat surface punya liquid saja. Okay, liquid surface saja, dia tak include the inner part of the liquid. Okay, it only happens on the surface of the liquid. Itu yang berlaku untuk evaporation process. Okay, so vaporization rate, it depends on the first one. Kita akan tengok a few factors lah. Ada 3 factors in total. The first one kita akan tengok in terms of surface area. So the larger the surface area, the higher the chances for the molecules to escape from the surface. So thus, when the surface area increases, vaporization rate increases. Okay, ni typo sebenarnya. There shouldn't be any U dekat sini. Sepertinya VAPORISATION. Okay, alright, so kalau kita tengok example diagram kat sini, kalau ada X, Y, Z dekat sini, so which one agak-agak akan vaporize easily? So of course Z will vaporize easily because it has a larger surface area. So surface liquid dekat sini besar, so yang dekat bahagian surface tu will easily vaporize into gas. Okay, compared to yang Y has the smallest smallest surface area, yang bahagian atas ni, so dia yang paling slow untuk vaporize lah. Okay, so X might be slightly faster compared to Y. Okay, but then it is still slower than Z. Okay, so Z should be vaporized easily dia punya liquid dekat sini because of the surface area. Okay, the second factor pula, it is the intermolecular attraction forces. So what do you think happened to liquid particles that has a strong intermolecular forces? Do you think it vaporizes easily ataupun tak? So strong attraction forces bermaksud dia kuat kan, so susah untuk dia lepaskan. Okay, so strong intermolecular process meaning lower vaporization. Okay, so tapi kalau weaker intermolecular process meaning easily vaporized than the liquid. Okay, so the weaker the intermolecular process the weaker the intermolecular attraction forces, the higher the evaporation rate, or vice versa. Okay, so kalau lagi kuat intermolecular forces, so lower the evaporation rate then. Okay, so yang ketiga ada kaitan dengan temperature. So this is the last one lah. So at a higher temperature, the molecules have high kinetic energy sebab dia gain energy kan. Bila ada temperature, so dia akan gain energy, so dia start moving around faster. So bila dia moving around faster, so dia akan boleh overcome the kinetic energy yang holds the liquid particles together. So dia akan lompat naik atas, dia jadi vapor. Okay, so more molecules that have enough energy to overcome the intermolecular forces that escape from the surface of the liquid. Thus the evaporation rate increases as the temperature increases. Okay, tapi kalau dia lower down, so evaporation rate akan decrease then. Okay, so in short, rate of vaporization increases when the surface area of the liquid increased, when the temperature is increased, and also when the intermolecular forces is between the molecules, they are weak. Okay, so ada tiga ni lah yang akan the three main factors affecting the rate of vaporization. Okay. Alright, so kita tengok sekejap condensation process. So condensation process pula adalah terbalik kepada vaporization process. So kalau tadi vaporization is from liquid to gas, meanwhile kalau condensation pula adalah from gas to liquid. Okay, so kalau kamu perasan, I'm not sure if you can see this. Okay, so bawah ni ada air, ke atas ni kita ada like the water vapor actually. Okay, so some of the water vapor bila dia dah lose energy dia dah kurang kinetic energy dia, nanti kamu perhatilah botol air kamu sendiri, you can see that ada water molecule on the wall of container, right? Okay, so sebenarnya itu adalah the vapor yang dah lose dia punya energy, and then dia turns back to liquid form. Okay, so boleh nampak dia berada dekat dinding tu. So some of the vapor molecule that may lose their kinetic energy during collision. Okay, so yang ni tadi we are not talking about ideal gas, so we're not talking about yang dia tak ada kinetic energy, no loss in energy tu tak. Okay, so some of the kinetic energy of kita punya gases dia akan hilang. So bila dia hilang through collision, okay, bila dia langgar lama-lama dia hilang. Okay, so they do not have enough energy to remain as the vapor molecule. Okay, so bila dia dah tak ada energy untuk remain sebagai gas, so what happen is bila dia gerak dekat the gas punya surface kan, dekat bahagian kosong yang atas ni, okay, dia bergerak ke atas ni, dia gerak, tapi gerak dia langgar, sometimes dia akan langgar surface of water tu sendiri. Okay, so bila dia langgar the surface of water, kalau dia dah tak ada enough energy to overcome the intermolecular forces yang ada dalam liquid, so what happen is it is trapped down. Okay, dia akan trapped by the water molecule, and then dia akan terus jadi water. Waktu tu dia jadi convert jadi water, dia transform jadi water. Okay, so if they cannot overcome the attractive forces, so these vapor molecules they return as liquid molecules. So this process is known as condensation. Okay, so now kita nak tengok pasal vapor pressure pula. So vapor pressure berlaku apabila the gas particles they keep on colliding one another and also to the wall of the container. Okay, so molecules that escape from the surface of the liquid they are referred as the vapor molecule. Okay, ataupun sebenarnya dia dalam bentuk gas lah, tapi kita panggil vapor molecule. So in an open system, bermaksud sistem yang terbuka. Okay, kita ada container tapi tak ada penutup. Okay, so the vapor molecules which evaporate off will diffuse away. Dia terus keluar daripada sistem tu. Itu dipanggil sebagai open system. Tapi if we have a closed system, again, sekali lagi, macam botol air ni, this is a closed system sebab dia tertutup. Okay, so what happen is kalau some of the liquid particles here, dia convert jadi vapor molecule pun, they are still trapped inside the container. Okay, so the vapor molecule which leave the surface, okay, they leave the surface tapi they cannot escape from the system lah. Dia orang cuma ada dekat bahagian atas ni sahaja. So in a closed system, they remain in the container and in contact with the surface of liquids, but they keep on colliding with the wall of container with one another at the same time, sometimes to the water surface. Okay, so these vapor molecules they are in constant random motion. So macam yang tengah bergerak tu. Okay, so they continually strike. Okay, sometimes they strike the wall of container. Okay, sometimes they collide with other vapor molecules. Okay, and then sometimes they collide with the surface of the liquid molecules. Okay, so ada banyak benda yang berlaku sebenarnya kat situ. So kalau dia berjaya to overcome the forces, the intermolecular forces with the liquid, so yang ni, yang kalau kamu tengok ni, yang ni dia berjaya lah, dia berjaya keluar. Tapi yang ni keluar terus macam as if sistem ni adalah open system kan. Sepatutnya dia just keluar daripada water tu je sepatutnya. Okay, sepatutnya dia trap dekat dalam ni. Okay. So every time the vapor molecule hit the wall of the container, so pressure is exerted. So the vapor pressure is the pressure exerted by the vapor at equilibrium with its liquid in a closed system. So kita akan tengok untuk closed system sahaja. So kat sini, so as you can see dalam closed system ni, so they move around in a straight line. So they collide with one another. So some of the liquid particles, okay, when they can on the surface, yang dekat bahagian surface ni, bila dia gain some kinetic energy, they can overcome the intermolecular forces, so dia akan convert jadi vapor molecule. Meanwhile, the vapor molecule pula, bila dia keep on colliding with the wall, with the other particles, nanti lama-lama dia hilang energy bila at some time dia langgar the surface, the water surface. So kalau dia dah tak ada energy, dia akan trap masuk dekat bawah ni, dia akan jadi liquid. Okay, so bermaksud dekat sini berlakunya vaporization process and condensation process at the same time actually. So IMF, intermolecular forces, and the vapor pressure. So kita nak tengok relationship dia sebenarnya. Okay, so liquid with a weak intermolecular forces are easier to vaporize. So easier to vaporize is said to be volatile. Okay, so perkataan volatile kat situ meaning liquid yang easily vaporized. Okay, so volatile liquids that have a higher vapor pressure. Kenapa higher vapor pressure? Okay, so this is because bila dia punya intermolecular forces dia adalah lemah, bermaksud dia punya kinetic energy dia adalah tinggi dan okay, sebab tu vapor pressure dia akan meningkat. Okay, so for example, kita ada intermolecular forces between dimethyl ether CH3OCH3 molecule, okay, which is weaker compared to the ethanol. Okay, kenapa sebenarnya? This is because less energy is needed to overcome the weak intermolecular forces in CH3OCH3. It is easier for the CH3OCH3 to vaporize. So sebenarnya kalau CH3OCH3 ni, dia cuma exhibit like van der Waals forces sahaja. Okay, dia ada dipole-dipole forces specifically sebenarnya. Okay, tapi kalau kita punya C2H5OH pula, dia ada hydrogen bond. Hydrogen bond is stronger intermolecular forces, right? Okay, so untuk kita punya CH3 ether, mesti panggil ether lah. Untuk ether kita ni, since the intermolecular forces is weak, okay, so less energy is needed to overcome the weak intermolecular forces. That's why they easily vaporize. So bila they easily vaporize, it is said to be more volatile compared to ethanol, because ethanol ni tadi dia strong intermolecular forces. So kalau strong intermolecular forces, susah untuk dia vaporize. Okay, so dia diconsidered sebagai less volatile dan. Okay, therefore kalau yang easily volatile ni, more volatile ni, meaning it has a higher vapor pressure dan. Okay, so kalau yang ni relationship antara IMF, intermolecular forces, dengan vapor pressure, bermaksud IMF strong, so vapor pressure, misalnya tak VP je, okay, vapor pressure akan berkurang. Okay, so kalau ether ni tadi dia cuma ada dia exhibit van der Waals forces je. Meanwhile ethanol pula dia boleh exhibit hydrogen bond which is stronger. Okay, so sebab tu vapor pressure kalau ethanol tu kurang lah. Okay, tapi kalau untuk ether tinggi vapor pressure dia sebab dia punya intermolecular forces kurang. What about between vapor pressure dengan temperature pula? So vapor pressure dengan temperature, kalau temperature meningkat, so more molecules have enough energy to escape from the surface of the liquid. Sebab kinetic energy dia semakin laju kan. So bila dia makin laju, bermaksud bila dia langgar-langgar tu, the pressure exerted adalah lagi tinggi lah. Okay, so the vapor pressure becomes higher. So thus the evaporation rate increases, which leads to a higher vapor pressure values. Okay, so boiling process. So kalau boiling process pula, kita tengok boiling process. So boiling process is actually bawah vaporization. Okay, kita akan nampak juga from liquid dia akan transform into gas. Okay, tapi dia perlu berlaku dekat a specific temperature and pressure. Dia bukan macam evaporation tadi. Evaporation, it can happen at any temperature as long as the temperature is below boiling point temperature lah. Tapi kalau boiling process ni, it has to happen at a specific temperature, and that particular temperature is what we call as boiling point. Okay, so unlike evaporation that occurs only at the surface of the liquid, kalau boiling pula it can occurs at the inner part of the liquid as well. Okay, not only on the surface, dekat bahagian dalam pun akan possible untuk convert jadi gas. So bubbles are seen during boiling. Okay, kalau evaporation tak lah. Imagine kamu pergi jemur baju kan, jemur baju tu kan evaporation process, mana ada kamu nampak bubble, tak adalah. Okay, yang dia bukan boiling tu. So boiling point is the temperature at which the vapor pressure of liquid is equal to the external atmospheric pressure. So once the boiling point of a liquid is reached, so the temperature akan remain constant for quite a long time during the boiling process, even though heat is supplied. So kalau macam water, the boiling point is 100 degrees Celsius, so dia akan remain dekat 100 degrees Celsius saja, sebab waktu tu kita punya vapor pressure of the liquid is equal to the external atmospheric pressure dah waktu tu. So the temperature will remain constant kalau untuk boiling point, kalau boiling process. Okay, oh sekejap. Okay, tak betul pula mismatch transition kat sini. So okay, so ini adalah secara generalnya the difference between evaporation and boiling. Okay, both are considered as a vaporization process whereby the liquid transform into gas. It's just that it differs in terms of condition dia. Kalau evaporation, it occurs only on the surface of the liquid and happen at any temperature below boiling point. Okay, tapi kalau boiling pula, boiling it can occur not only on the surface, it occurs in the inner surface of the liquid juga. Okay, in the inner part of the liquid, and it happens at a certain temperature. So for example, water, it happens at 100 degrees Celsius. Kalau macam minyak, it should be lower than 100 degrees Celsius. So ada beza lah, any other liquids ada beza dia punya boiling point. So the temperature at which the liquid starts to boil, that is what we call as the boiling temperature lah. Yang certain temperature tu tadi, that is what we call as the boiling point. Okay, so boiling point dengan vapor pressure pula, apa pula relationship antara boiling point dengan pressure? So boiling point of a more volatile ni meaning it is easily vaporized, right? So boiling point of the easily vaporized liquid bermaksud lower lah dia punya boiling point, dan sebab dia senang je nak vaporize because intermolecular forces adalah lemah. Okay, lemah, therefore do we need more energy to overcome the intermolecular forces then? No. Okay, so untuk yang volatile liquid, so the boiling point rendah. Okay, so for more ni it will exert, so kalau yang ni terbalik pula, but if something that is apa ni tadi? So for a more volatile liquid, it will exert a greater vapor pressure. Vapor pressure untuk volatile liquid dia lagi tinggi. So compared to a less volatile liquid at the same temperature. Okay, therefore kita boleh cakap yang attractive forces ataupun IM tadi lemah dan the non-volatile liquid. So that is why a more volatile liquid, dia ada weaker intermolecular forces ni tadi, it needs less energy to vaporize. Okay, so for the vapor pressure to reach the atmospheric pressure, so it boils at a lower temperature. So vice versa untuk the one that has less volatility dan volatility. Liquid that has less liquid that is less volatile, so dia punya vapor pressure pun rendah juga, bermaksud intermolecular forces dia kuat, so it requires more energy in order for the liquid to vaporize. Okay, so that the vapor pressure boleh reach at the atmospheric pressure. So kalau macam tu, kalau yang less volatile, it boils at a higher temperature. Okay, so conclusion, the boiling point of a more volatile liquid is lower than a less volatile liquid. Okay, therefore the weaker the intermolecular forces, lower boiling point, the higher the vapor pressure. Boleh tengok relationship antara tiga benda tulis kat sini. Okay, IMF weaker, so BP pun rendah. Okay, tapi in terms of dia punya vapor pressure tinggi. Okay, so apa pula kaitan dengan volatility? Okay, volatility pula, mari kita tengok the next slide. So IMF boiling point dengan vapor pressure tadi kan. So basically for volatile liquid, it has lower IMF. Okay, so less energy is needed to overcome the attractive forces. So the higher the rate of the evaporation, then the higher the vapor pressure, so lower boiling point. Meanwhile, kalau non-volatile pula, so dia ada higher intermolecular forces, meaning lower rate of evaporation, lower vapor pressure, so higher boiling point then. Okay, so that's all class. We're done for liquid. Okay, thank you. Bye-bye.